All right, welcome to The Explainer. Today, we're going to play doctor, but for a code. We're putting on the white coats to diagnose a really common and kind of subtle problem called feature envy.
So what if your code is trying to tell you something? Seriously, think about it. Sometimes the way a program is built, it's like a symptom, right? A little sign that there's a deeper design problem hiding underneath. It's not a bug, it's not going to crash your whole system, but it is a little hint that things could be, well, a whole lot healthier.
And that's what brings us to this idea of a code smell. If you've been around software development, you've probably heard this term. It was coined by the legendary Martin Fowler, and honestly, it's the perfect place to start our diagnosis.
Okay, so what is a code smell exactly? Super important to remember. It's not a bug. Your program is going to run just fine. It's more like a yellow flag, a warning sign on the surface that hints at a potential weakness in your design. It's that first little symptom that makes you go, something's not quite right here.
Let's break this down with a super simple analogy. Imagine a baker. They've got their flour, their ovens, the whole setup, but every time they need to chop something, they run next door to the butcher's shop just to borrow their knives. I mean, you'd think that was weird, right? You'd be like, hey, why don't you just get your own knives? Well, that's exactly what we're talking about in our code. It's when a piece of functionality is constantly going somewhere else to get its tools.
Okay, so with that image in mind, the baker running to the butcher, let's get specific. Our patient today has a very particular code smell, and its name is feature envy. Time to make the official diagnosis.
So here it is, the textbook definition. Feature envy is when a method, a function, seems way more interested in some other class than the one it's actually living in. It's constantly reaching over into another object, grabbing its data, using its stuff to get the job done.
And I just love how Martin Fowler talks about this. He says the method literally envies the other class. It wishes it could just pack up and move in over there, right next to all the data it's always using. When you think about it like that, as this jealous piece of code, the whole concept just clicks, doesn't it?
All right, let's open up the patient's chart. This is a classic example you'll find in a lot of the literature. We've got a method here called calculate weekly pay. And where does it live? Inside a class called hourly pay calculator. Okay, on the surface, that sounds totally reasonable, right?
But take a closer look at what's actually happening in the code. This calculate weekly pay method, which lives in the calculator, is spending all its time talking to the hourly employee object. It's constantly reaching over, asking for the employee's pay rate, asking for how many hours they worked. It's pulling all this data out just to do a simple calculation.
And this is a textbook case of the symptoms. The method is in the hourly pay calculator, but it is obsessed with the hourly employee. Look at it. It's calling get 10th rate, get 10ths worked. It's grabbing all this data that really belongs to the employee. It's like it's more interested in the employee's business than its own.
So what's the big deal? Who cares? Well, you should, because this kind of envy leads to really messy, confusing code. You end up with these weird hybrid things that are kinda sorta one thing, kinda sorta another. The experts literally call them the worst of both worlds because they're hard to change and they're hard to add to. It just creates a maintenance nightmare.
Okay, diagnosis complete. The patient has a clear case of feature envy. But don't worry, there's good news. The treatment is actually pretty straightforward. Let's write up the refactoring prescription.
The guiding principle here is so simple but so powerful. Ready? Keep things that change together in the same place. That's it. Your data and the functions that operate on that data, they should live together. They should be best friends.
So our prescription has two main options. First, there's the move method refactoring. This is for when the entire method is envious, just like our pay calculator example. You literally just pick it up and move it to the class it's jealous of. Easy. The second option is extract method. You use this when only part of a method is envious. You just pull that little piece out, turn it into its own method, and then move that over.
And just look at the after picture. It's so much cleaner. Before, you had these two classes in a really awkward long-distance relationship. But after we apply the move method treatment, bam, the pay calculation logic is now right inside the hourly employee class. The data and the code that uses it are finally living together. It just makes so much more sense.
And just like any good medical treatment, this refactoring has some amazing long-term benefits for the health of our entire code base.
Yeah, the prognosis is fantastic. First off, you get way less code duplication because all that data handling logic is now in one central place, and the organization is just so much better.
Now, if a new developer wants to know how pay is calculated, where are they going to look? Inside the hourly employee class, of course. It's intuitive.
But wait a second. Before you run off and refactor everything, there's a catch. Just like in medicine, not every symptom points to a disease. Sometimes what looks like a problem is actually a necessary, even healthy part of the system. Not all envy needs to be cured.
Let's look at one more patient file. This time, we've got a report hours method, and it's inside an hourly employee report class. Now, if we're being honest, this method is definitely envious of the hourly employee class. I mean, it reaches in, grabs the employee's name, grabs their hours, all to create a nicely formatted report.
So do we move it? Well, in this case, absolutely not. Here, we want to keep the reporting stuff separate from the core employee data. And think about why. What if the business wants to change the report format next week? You don't want to have to go and modify your fundamental hourly employee class just for that, right? This is a deliberate design choice. It's what you see in classic design patterns like the strategy or visitor pattern, where you intentionally keep behavior separate from the data.
So really, it all boils down to this one key takeaway. The golden rule is, put your code right next to the data it works on. That's the foundation of good object-oriented design. But, and this is a big but, like any good rule, you have to know when it makes sense to break it, and you need to have a really good, intentional reason for doing so.
And that's pretty much the whole story. So next time you're digging through your own project, I want you to put on that doctor's hat, take a hard look at your classes, and just ask yourself, are any of my methods spending a little too much time peeking over the fence at their neighbor's data? Go on, take a look. You might be surprised at what you find.